So I know you learned about exponents before and exponentials, and this isn't just about exponents. That would be like algebra 1. But boy, do we need to know exponents, because like literally one of my smarter kids last hour, when I asked about these, was messing them all up. The zero power messes a lot of people up. Whether or not it's got parentheses messes people up. Negative second power messes people up. So I'm going to talk about these for just a second. And I think the easiest way is to go through an example like this. What is 3 to the third? Just that. What's 3 to the third? Well, 3 times 3 times 3, right? What's 3 times 3? 9 times 3? 27. All right. Please write this down. Go off to the side, write 3 to the third is 27. Then we're going to keep going down and make sure you get the weirder powers. 3 to the second, well, that's easy. What's that one? 9. 3 to the first, what's that one? 3. Now we get to the weird power, 3 to the 0. Now, if you look at the pattern here, some people are going to think it's 0, but that doesn't make any sense. This goes 1/3 as big, 1/3 as big. This should be 1/3 as big, which is 1. Do you get, in a way, we could say divided by 3 each time? Do you get 27 divided by 3 is 9, and then 9 divided by 3 is 3, and then 3 divided by 3 is 1. So it makes sense that it's 1. It's not to the... When you put something to the 0 power, it's not 0. It's 1. All right, now we're going to go under 0. 3 to the negative 1. Now think about this for a second. Should the answer turn negative? No. Because look, it's just been dividing by 3 each time. You think it's going to stop dividing by 3? No, it's going to divide by 3 again. That's the whole point. It just keeps dividing by 3. So this one, what's 1 divided by 3? It's 1/3. So do you get that to the negative 1 power makes it the reciprocal of it? 3 turns into 1/3. All right. And then one more. 3 to the negative 2. If you get this one, you can get all the rest of them because it'll be like that. We're dividing by 3 every time. That's the same as multiplying by 1/3 every time. That might help because now you have 1/3, and dividing by 3 is going to be weird. Wouldn't you agree that timesing by 1/3 is like dividing by 3? And so what's the answer? 1/9. Now, I like to, if I'm looking at this chart, to me that makes total sense. I like to, though, think of this as the negative makes the thing turn into the reciprocal of it. So I had a 3, and then it turned into a 1/3. And the negative squared means I take the 3 and I square it, which gives you the 9, and then I put 1/9. So it's almost like there's 2 parts to it. All right, now we were going to do the same exact thing, but we're going to do it with a negative number. And I want to show you what happens. Negative 2, we're going to put it to the third. Then we're going to put negative 2 to the second, negative 2 to the first, negative 2 to the 0, negative 2 to the 1, and negative 2, to the negative 1, sorry, to the negative 2. There. And I hope you catch on to the pattern. That cell phone? Oh, that wasn't a cell phone. Okay, I thought you were slipping the cell phone in your pocket. Just adjusted. All right. Figures. Can you tell me what to do?
For negative
To the third. Is it negative 8 or is it 8? Negative 8. How about negative 2 to the second? Notice it's positive. Because it's a negative 2 times a negative 2, which makes it positive. How about negative 2 to the 1? Negative 2. You see how it's alternating? Negative, positive, negative. Mr. Goal, can you tell me what's next?
Positive.
Positive what?
1.
1. Yep. Anything to the 0 power is 1. Rissy, when I take -2 and I put it to the -1, does the answer turn negative? But is it because I put it to a negative power? No. Negative powers don't turn things negative. The reason this one's negative is because I'm going to flip a negative number and it stays negative. And every other one's negative. So the next one should be positive, shouldn't it? So I think of this as 2 parts. I go, what's -2 squared? And then I will put 1 over that. -2 squared is 4. And then I will put 1 over that because of this negative here. 1/4. Maybe you guys had that one right? Who had that one right? Okay, good. All right, so that's what's critical about exponents. Now, let me remind you what they taught you in higher algebra. Everybody write this out. Y equals 8, parentheses 2, to the x. At the end of the chapter where you learned this stuff in Algebra 2, you could have been asked, what was the start value of this exponential function? Don't overthink it. Somebody say what the start value was. And you forgot this stuff, and that's okay. That's what I'm here for. I'm going to remind you. That is the start value. Let me explain why it's the start value, but everybody write that down and then write start, because this is what's really critical about this. That's the start. The other number is what you'll end with, goes here. Your end value is the y. In an exponential function, your start value is always like at time 0. Would you agree that that's x equals 0, that's x equals 1, that's x equals 2, that's x equals 3? At time 0, it's like you started right there. Christopher Reeves was chosen as the actor for Superman, the first Superman movie. Okay, so you can imagine the pressure. He's got to be like pretty strong looking to be Superman. And when they first did, when he auditioned for the role, he wore really bulky clothes, so they couldn't tell that he was skinny, because he knew he was probably too skinny to be Superman. But they hired him and said, okay, you're going to be Superman. And then they realized, oh crap, we put you in the suit, you don't look strong at all. You're supposed to be the man of steel, you're supposed to be super incredibly strong. And so they said, we can make a padded suit, don't worry about it, we got a padded suit for you. But he wanted to be like, no, I don't want to be the guy I had to wear a padded suit. I want to actually bulk up. So he's told this story about he worked out 5 times a day. No, wait, he ate 5 times a day and worked out with incredibly heavy weights to just build bulk. And he was able to go from like, I don't know, like 180 pounds to like 220 and mostly muscle. So he was like, he really was big. If you see the pictures of him. My point, though, he's had a start moment when he was at like 185 pounds. And then his weight grew from there until eventually he got to like 220. But his starting number was not super impressively sized guy, and he's supposed to be like strongest man in the world kind of thing, so he better bulk up. That was at time 0. That was if this is 0. Think about it. If this was 0, do you get this whole part cancels out? And so that is your start value. For him, if I was going to write an equation for Christopher Reeves as he got all bulked up for Superman, it would have been, he started at like, I don't know exactly how big he was, but I know at the end he was like 225. 185, and then this is the base, and then this is the x. So your start value goes there. Sad ending story for Mr. Reeves is that he was riding a horse and he got bucked off by the horse and he broke his neck, and he ended up being a paraplegic. No, I believe it was a quadriplegic. for the rest of his life. And that shortened his life, too. He ended up dying of an infection, which sometimes happens when you are in bed a lot, is you can get bed sores. And it's just really sad to see somebody go from like one of the most powerful, strong, and playing that on in a movie to like being a quadriplegic. It's one of the things that they're trying to fix with that Neuralink. They have the first Neuralink implant in a human, which allows them to control a computer with their brain, which actually isn't, that's not the first time that's been done, but what they think they can do is eventually create an exoskeleton for humans so that you can control the exoskeleton that you would stand in. It would be like a body frame thing, and you'd be able to walk around again using your just thoughts, just like anybody else does. They use their thoughts to walk. Someday we may be able to do that. And the first little step of that is this Neuralink, which, again, was successful. The guy was interviewed the other day, and he's like, it's changed my life. I used to have to ask everybody to do everything for me, but now whatever you can do on a computer, he can do. Because he can click everything he wants to. He can search the internet. He can type out notes. He can all that stuff just using his brain. Okay, back to this. Start value goes here. How do you get this number? Well, that's called the base. And if that number is bigger than 0, it's going to make the number grow. If this number is smaller than, wait a minute, I said it wrong. I'm going to say it again. I'm going to call this B instead of 2 because we don't know for sure what that base number is. So I'm going to put a B right there, and you should too, please. Everybody write that's B, and that's called the base. And if B is bigger than 1, you're going to grow. And if B is less than 1, it's going to, what's the opposite of grow? Shrink. Okay, so your start value goes in front. Your base, if it's bigger than 1, it's growing. If it's less than 1, like a fraction, like 1/2, then it's going to shrink. And the x is always in the exponent, and that's what creates an exponential. So let me give you an example of some things that aren't exponentials. Y equals x to the x. Nope. The x is supposed to just be in the exponent. Here's another one that's a nope. This would be an exponential, but all of a sudden, if I make the power weird, like, oh, I'm going to make it the square root of x. Yep, you can't have weird powers. If the power is not a normal x, then watch out. It's probably not going to turn out to be exponential. So some of the first questions we have on the Schoology quiz for today is just, is this exponential or not? So just look for the power and look for the x. If the x isn't in the power, not exponential. If the x is a weird power, then it's not an exponential. All right, big slide right here. Do you get that the 1 is growing? Well, duh, it's going up. The other one is decay, that's going down. I just want to give you 2 real-world examples. Health insurance has done this. When I started as a teacher, it was only like $50-60 a month to add your family to get health insurance. $50 or $60 a month. It was really cheap. Might even be cheaper than that. Now it's over $1,000 a month that I have to pay to add my family to my health insurance. Imagine going from $50 a month to $1,000 a month. It's that kind of a graph. It's like that crazy difference. So health insurance costs have just gone up insanely over my 30 years of teaching. All right, here's another one that's also happened. During my time teaching, the cost of a flat screen TV, the first big ones that were like the size of this board here, the smart board in the room, things that big, that's literally like a $15,000, $20,000 TV at the very beginning. And now you can get one for probably $800. And you can get a flat screen if you get a small one. You can get them for like $300, $200, $150 for a flat screen TV. And they used to be like $8,000, $10,000, $15,000. So flat screen TVs have definitely done this. Electric cars are in the middle of doing that. Just a few years ago, $100,000 for an electric car. And literally within the last 3 weeks, there's a Chinese company that just announced that they have a $10,000 EV. $10,000 electric car. The average car in the U.S. is $45,000. So compare that. If you can get a $10,000 electric car that's actually faster than most gas cars, like when you step on the gas, so to speak, it's not gas, it's electricity. My point, that the electric cars are doing this too. And that means they have a start, whatever their start number is. It's wherever, it's along the y-axis here. Their start. And then since it's decay going on, this is some decimal, like 0.8. Something less than 1 to the x. You getting the idea of what exponentials are? There's exponential growth, exponential decay. The start number goes here. If this number's less than 1, it's shrinking. That's exponential decay. And there's always an x in the exponent. And if you do anything weird to the power, it won't be exponential anymore. Okay, I think we're kind of caught up. Now, without going to the next slide, I would like to just show you, here's the typical hard test question about this. Now remember, we're on day 1 of the unit. I get them throwing a lot of stuff at you that you're supposed to remember, didn't remember. Hopefully you got it refreshed now so you're good at weird exponents. You know what an exponential function generally looks like. But I'm guessing there is 0 kids in the room who can do this. And tell me what the exponential function is for that. But in a minute, you'll all know how to do it. I've just given you 2 data points. From that, you can write an equation for an exponential that at the end is going to look like this. I'm not saying for sure that it is this. I'm saying that it's going to look like this. Would you agree that it's growth? It's going up. So you could know that this number has to be bigger than 1. So let's say it's like 2.3 or something to the power of x. It looks something like this. It's just I got to figure out what the start value was. And I've got to figure out what the base is. If I knew those 2 numbers actually, then this is what my equation looks like. I bet you there's somebody who can tell me how to start the problem. What's the start value? 0 is a good guess, but that's wrong. The start is not 0. The start value isn't 0. Yes? Yes. That is your starting point. And so 0 tells you on the graph you'd be like here at 0, 12. That 12 is the start value. So then this isn't an 8, it's a 12. Do you get how I got that 12? Then somebody tell me 2.3 was a completely made up number. What should I put there since I don't know what it is? B. Good. Okay, now what? Come on, you can do this. Use logic. What logic am I supposed to use? Well, we already used 0, 12. Don't you think we probably need to use the other data that I gave you? The 2 and the 24. And what do you think I should do with them? Take a leap, Ava. Where do you think I should put the 2? Good guess, but no. Otherwise, what would I do with the 24? So put the 2 in where? Where the x is. See, it's an x value, isn't it? And then, go ahead. You can do this. Hint. You told me the x was 2. Now you're telling me the 24 is b? No, it's not that. Yeah, the y is 24, so that goes here. So I'm going to put the 24 here and the 2 here. Everybody copy that down, and then we have to solve it. I'll show you how to solve it. We just put the 2 from here in the x spot. But we still don't know b. I know, we're going to solve for b though. Bodie, I've got 24 equals 12, parentheses b squared. Tell me what you think we do to solve this thing. Divided by 12. What's this? Now what? Yes, but I'm going to put 1/2 power. You guys agree that 1/2 power means square root, right? I reminded you that earlier this hour. So then why did I do that? Because that turns into a 1, and b to the 1 is just b. What's that? Square root of 2. It's the square root of 2. Nobody knows what that is. The reason I say that is it's because of decimal. It goes on forever and it never repeats. So my base is the square root of 2. You wouldn't have guessed that one, would you? How'd I get that again? Because I put the 1/2 times the 2, and I put the 1/2 power here, just like I did over here. And 2 to the 1/2 means square root of 2. There it is. You want me to have a decimal there? I could. Use a calculator and figure out the square root of 2. It'd be like 1.613 or whatever. It'd be some decimal. And now a really common mistake is to be like, yay, I solved it, I'm done. No, you're not. The whole point was to write an equation like this. Y equals the start value, which we know, times some base value to the x. But we know the base now. The base, square root of 2. Is the square root of 2 going to be bigger than 1? Square root of 2 means like, well, I'll tell you. Here, I'll get Siri to tell me. What is the square root of 2? 1.4. Does this being about 1.4 means that we still have growth, right? Okay, good. And what was our start value? Well, look back at the chart. Start value is this guy. Start value is 12. So 12 goes right there. And that is your equation. A lot of people feel like they should put in more stuff. No, you need an x and you need a y to have an equation. If all you have is y equals, like, if I put in a number here, then I don't even have an equation anymore. It's just like y equals, and you could figure out the answers, like 16 or something. That's not an equation. That's just a solution. To have an equation, you need a y and x. All right. We're going to do another one like that. This one, I'm just going to use the slide to remind you. I spent too much time on this last hour, so I'm not going to take tons of time here. E is a decimal you're supposed to know. Just like if I said pi, you're supposed to go, oh yeah, that's 3.14. 0 kids last hour remembered what E was. It's a decimal. See, anybody in here has a better memory. If you had to estimate it, because it's a decimal that goes on forever, like pi. So 3.14 is a good estimate for pi, but what the heck is E? Anybody know? Nobody can beat last hour? All right, then write this down. You're supposed to know what E is. It's going to come up. E is 2.718. Do you agree if I wanted to round that, it would round to 3? Or if I wanted to round it to a different spot, it'd be 2.72. It's a decimal. It's just a decimal. You're supposed to memorize E, just like you're supposed to memorize pi. Okay? So if I show you y equals e to the x, you can totally replace that with about 2.7 to the x. E is a decimal that we already know. So does this represent growth? Yeah. What if there's no start value? Do you think the real start value is really 0 then? Or wouldn't there be some other number in the front? What would the number be? 1. If they don't give you any other start value, they're saying it starts at 1. That happens a lot. So the start value here is 1. This is telling me it's growth. There's an x in the exponential, x in the exponent, so I know it's exponential. All right, moving on. Let's do this one. If you stick in -1 in this little problem, is it exponential? Yeah, there's an x in the exponent. Can you stick in x is negative 1. Well, I can. I put it right here. Do you know what negative 1 power means? Turf, it's not 1/3. It's 1/3 to the negative 1, which is 3. Yep, the 1/3 just flips. If you'd said 3 over 1, I would have respected that too. Sabins, let's put in 0 together. Where am I going to put it, first of all?
Exponent area.
Yep, so x is 0, so I put a 0 here. What does 0 power mean?
It goes to 1.
Answer's 1. There you go. Bridger, I'm going to put in 1 now. Where do I put it? Yep. What's the answer? Yep. Do you get, if you graph these, you get exponential decay? I almost said growth, but then I looked at that and I was like, ooh, wait, it's under 1. So that would exponential decay. This is shrinking. If I graph those 3 points, look at that. I just graphed the 3 points we had, and it's one of the decay kind. Moving on to this slide. This is where they're just reminding you B is the base. Initial value, I call it the start value, is when x equals 0. Because if you put a 0 right here, this is all going to turn into 1. And then 1 times a means that's what you start with. If x is 0, that'll be your start value. Right on to this slide. Is this exponential or not? A, is that exponential? Yeah, there's an x in the exponent. Some people might be annoyed there's no starting value, but couldn't you just put times by 1 in front? Yeah, you could. So this is an exponential. How about that one? Is that an exponential? No. It has an exponent, but the x isn't in the exponent. Do you get the difference there? It's an equation, but it is not exponential. The x is in the wrong spot. It should be up in there. Not exponential. Okay, how about this one? Exponential? Yes, because it has an x in the exponent. That's all you really have to look for, except if the x is weird. Hint, what happens with the negative exponent? All right, so honestly conflicted right now because I know that negative exponent makes this turn into a flip of itself. So this would turn into like 1/2. So couldn't I just get rid of that that negative exponent by flipping the base? Isn't that what happens when I do the negative exponent? Is this just flips over? I'm pretty sure this is exponential because, yeah, in fact, I know it's exponential. It just happens to turn it into exponential decay. See? The negative can just flip this. So it's okay for that to be negative. All right. So that last one is exponential. Okay. And then here is a typical test question. And I get it. I just taught you a whole ton of stuff, but the most important thing would be this. Where is the start value? Please talk to that kid next to you and determine which of these tells you the start value. And what is the start value? Talk to the kid next to you. It would be this one. I get some of you are like, this is the first point, so that's the start. Nope. The start value has x equal to 0. You remember when I was doing the Christopher Reeves example, I said his weight was like 185, and that's the start value because it's the y-intercept. Okay, so that's the start value. So then the start value for this problem should be a 4. How'd I get that? Because the x is 0. It gives you the y-intercept, and that is the start value. So y equals 4 times some base I don't know to the x. Only thing I got to figure out is the base now. I'll do that by plugging in something into x and something into y. Ava, you did this for us last time, so you're probably best at it. Would you please use this point right here, because I think it's the easiest numbers, and tell me what goes where. A 1 goes in for x, and 12 goes in for y. 12 equals 4, b to the x is 1, I guess, so I'm just putting a 1 right there, yes. And then you can just solve that for b. All right. Graydon, tell me what to do. By 4, and I get 3 equals b. Does that feel right to you so far? Okay, good. So then, what's the actual equation? I now know start value. I now know b. Tell me the equation. You always start with y equals.
Y equals 4 parentheses x.
To the power of x. There you go. You should ask yourself, how do I start? With the start value. What is the start value? It's the thing on the chart where x is 0. It's right up there, 0, 4. So then I guess 4 is the start value. Go. And then this 3, how do we get that? We got that by sticking in the 1 and the 12 in the equation right there, and then we solve for b, and we got b equals 3. So there's your equation. Start value is here. We solve for b by sticking in the 12 and the 1 from here. All right. Now let's go find your assignment. Everybody go to the school quiz. We're going to do the first couple problems together. Then you'll have some work time, during which I'm going to hand your test back. You're not going to have much time to do corrections today, but at least you get a feeling for how you did, which ones you made mistakes on. Those of you that haven't taken the test, it's no big deal. You just have to take it soon, and I'd like to talk to you about when you're going to take it. All right. Question 1 is just, is it a function or not? Turf, or not, sorry, is it an exponential or not? So would you read me number 1, Turf?
Y equals x
To the power of?
8.
All right. Is that an exponential? No. If they made you say y, it'd be because the x isn't in the exponent. All right. How about number 2, Turf?
Y equals 5x.
Is it?
5 to the power.
Oh, to the power of x. Is that exponential? Yes, because the x is in the exponent. How about number 3, Turf?
F of x equals
Same thing as y equals
like 3 wrapped in the square root.
3 square root of 3, or what are you talking about?
Like
Like this?
No, yeah. To the x.
Is it a power or not?
Yeah, I think.
The x, is the x in the power spot?
No.
It's like a tiny 3 in the square root over. It's weird.
Like
Yeah.
that?
Yeah.
Okay. So, once again, is the x in the exponent? No. So then it's not, this is a no. To keep asking yourself, is the x in the exponent? No, the x is not in the exponent. So. Okay, number 4. Brady, would you read me number 4?
Y equals x to the power square of x.
If they do anything weird, well, first of all, x is only supposed to be in the exponent, so this one's out. Not supposed to have an x there. Even if they had just had the square root of x, it's a weird power, so I would have been suspicious. But this one for sure is out. Nope. Because the x is only supposed to be in the exponent. Brady, number 5.
Y equals 3x to the second power.
Is the x in the exponent? Nope. All right, I think you get the idea on those. Let's skip all the way down to number 9. Christy, would you read me the chart for number 9? I think it gives you an XY chart. It's x, f of x, and g of x. Is g of x first or is f of x first? Okay, thank you. Rissy, would you please read me the row? There's three numbers underneath x, f of x, and g of x. Awesome. Can you just up the volume a little bit for the next row? Oh, like we're supposed to figure that out. Okay, keep going. 3/2. Okay. We'll figure that out later. Okay, and then keep going. Is that it? Okay, awesome. Now, if they ask me for f of x, you can just ignore the whole g of x, and that's what they do first. So, Noah, read me the actual question for number 9, part A. And part A is to do f of x? I think, isn't it? Okay. Look at it close. I think part A is supposed to ask me to figure out f of x. Can you verify that? Okay, good. Then, I'm going to look for that point right there. Bodie, do you know why I picked that point? It's the starting value, because the x is 0. So that's my start value. Cool, I already know my start value. The start's going to be 3/2. Can I just write the whole equation? No, but I can start it. 3/2 times the base, which I don't know, to the x. Now, if I only knew another point for x and y, I'd stick them here, and I could solve for the base. Caden, what point do I know?
You can do 3/8, or
Yeah, you're picking this point. That's totally fine. That'll work. So x is 2, and y is 3/8. Now, I've said this before, and the calculus teachers say it often. That wasn't hard to realize that I could stick in another point. The 2 goes here and the 3/8 goes here. It's not that the pre-calc is hard. It's the algebra. You've got to solve that now. So how do you solve it? Well, look, one of the steps I've told you is if you can factor it, you should. There's nothing I can factor, though. But could you clear the fractions? That's another strong strategy. So I times everything by 2 and by 8. But even better than that, I could times it by 8. If I just times by 8, it'll fix the 2 and it'll fix the 8. Now, you could have multiplied by 2 and 8. It would have been okay, but then you just have to reduce things more. This 8 will cancel this 8, and it's not a fraction anymore. This 8 divided by 2 will give you 4. And then 4 times 3 is 12. Okay, what I just did there? I just times by 8 to get rid of the fractions. I could have times by 8 and 2, and then I'd have to reduce more at the end. Okay, it's not so much the pre-calc, it's the algebra that's hard. Winston, what do I do next to solve this thing? Yes, a lot of people would have said square root, but you are correct. Get rid of the 12 first, and then we will square root. And we should simplify a little bit. Maren Sabins, what's 3/12 the same as? 1/4 equals b squared. Now, Xavier, how do I get rid of a squared?
You gotta do the square root.
You are correct. I'm doing the 1/2 power for my square root. You could have done a square root symbol for the square root, you know, like a square root like this. I'm fine with either one of those. I'm going to do the one that has the 1/2 power. And then this just becomes b. And then this is 1/4 to the 1/2, which means the square root. So that means the square root of 1 over the square root of 4, and those both work. What's the square root of 1? 1. What's the square root of 4? 2. Oh my gosh, I figured it out. B is a half. Winston, am I done then if I figured out B is a half? No, you got to write the equation. The equations always look like this. Y equals the start times the base to the x. But we know those two now. So, Winston, what's the start and what's the base?
What's the start again?
It's over here in the chart.
3 over 2.
Yep.
And then B would be 1 over 2.
Yep. And there's your equation. The only pain in the butt is actually putting it into Schoology. It's 3/2, and then this part's got to be in parentheses, 1/2, to the power of, do you guys know how to do that on Schoology? Power of x. That's what you type in. Unless they give you the y equals already, that you don't want to say y equals, you know, like if they already gave you the y equals. Did they give you the y equals? Does it say f of x?
Yeah.
Oh. Does it like write out the f of x? So then I probably don't even need this part. Know what I mean? If they already gave you the f of x, then I just need this. If f of x was in the answer already, then you just have to type in this part. All right, that was a tricky one. That's why I did it with you. But always on the first day of a new unit, I feel like everybody leaves here a little confused. Just understand, that's why the test isn't tomorrow. We have a whole like week and a half at least to practice this. We'll revisit it. But if you don't do your homework tonight, this is always a critical night. You don't want to get lost on day 1 of the unit, or you're going to stay lost for a long time. Okay, that's all I got for you for today.